This video is the third video for section 8.1. It's not going to complete section 8.1, but going to get through all but the last example. So we're going to be looking at summation notation in this video. And here is sort of our definition page. So this is definition of summation notation. So basically what we're doing is we're taking all the terms of a sequence and we're finding the sum of them. So this Greek letter sigma means sum. So when you see that, you should just know I'm adding up these terms. They don't even have to give you the word sum. Couple of vocabulary things. The index here is the I. And then the lower limit would be 1. So we're starting when I equals 1. And this would be the upper limit. So for example, if we have something like this, I equals 4 to 10, that's our lower limit of summation and our upper limit. Notice it doesn't have to start at 1 or 0. It can start at anything. I'm going to cover up here and then show you where these numbers came from. So this is example 8, and you have the summation symbol, so you know you're adding up the terms here. The first one is going to be when we replace I with a 1, and then we're going to replace I with a 2, a 3, a 4. We're going to stop when I equals 5. So when I equals 1, instead of 3 times I, we're going to have 3 times 1. When I equals 2, I'm going to put a 2 here. So that will be 3 times 2. When I equals 3, when I equals 4, when I equals 5. So every time I'm substituting in these values of I into this expression. Remember, pause the video and copy this in your notes. You do want all the details in your notes. And then you can simplify that. If you notice, 3 is a common factor, so I could factor out the 3, and then I'm just adding 1, 2, 3, 4, 5, and I get 45. All right, next example, same idea. They're calling the index K here. Doesn't matter what letter they use here, but notice whatever letter they use here will be the same letter here. So the first value of K that we're plugging in is 3. So I'm going to have 1 plus 3 squared. Then I'm going to plug in 4, 1 plus 4 squared, 1 plus 5 squared, all the way up to 6. So that's what it will look like. So each one of these parentheses looks exactly like this expression here, but I'm substituting in 3, 4, 5, and 6. And then simplify that. 9 plus 1 is 10. 4 squared is 16 plus 1 is 17. 26. 6 squared is 36 plus 1 is 37. So my sum is 90. So not really a lot different than what we did with our sequences, except now instead of listing our terms, we are adding them up. This one we are going to do on the video, and you will need your calculator for this one. So you might want to pause the video and get your calculator out. All right, so we're going from n equals 0 to n equals 8. So this is my n. Remember, these letters will always match. So my first term will be 1 over 0 factorial plus 1 over 1 factorial. You're kind of getting the hint here. Now we need to go all the way to 8. So I'm just going to keep writing them. 3, 4, 5, 6, running out of room, 7, 8. That was a little overkill. Probably could have stopped that at like 5 or 6. I feel like you get the idea. Okay, now some of these you should know. 0 factorial is 1. 1 divided by 1 is 1. 1 factorial is 1. 1 divided by 1 is 1. 2 factorial is 2. 1 divided by 2 is 1/2. 3 factorial is 3 times 2 times 1. That's 6. So this is 1/6. All right, now when you get to these, maybe you don't know these. This is 4 times 3 times 2 times 1. You could write it out, right? But you can also do factorials on your calculator. So if I want to do 4 factorial, I'm going to put in 4, and then I'm going to go to the math. and I'm going to go all the way over to prob or problem. If you look, menu item 4 is factorial. So then it puts the factorial symbol after your 4, and you get 24. So this will be 1 over 24. Let's do one more. Now I want 5 factorial. 5, math, prob, and then menu item 4. 5 factorial, 120. It will be helpful if you can memorize a few of these, like 1 through 5 is helpful to memorize. 6, math, prob, menu item 4, 720. Okay, so you can do some of those on your calculator. Let's see, 1 over 7 factorial is 1 over 5,040. And 1 over 8 factorial, these grow fast. This is 40,320. All right, you would put all that in your calculator and you're going to get a decimal, which is 2.71828. Do you recognize this number? Recognize this? This is E, or e to the 1. If I go to my calculator and I do second natural log, e to the 1 is 2.718. So this is the series that generates the number e. One last thing for summation is just some properties. So this says if you have C, so C would just be a number. So say you have something like this, I equals 1 to 6 of 6. Your answer is just going to be 6 times whatever this number is. So you don't really have anything to substitute it in. So it's saying it's going to be that constant times your upper bound. This also says if you have a constant, so say you had this, I squared, I equals 1 to 7, you can take that 6 out front and then do your summation on the I squared. That's sort of like this one where I factored that 3 out. We could have taken that 3 out front, found all these numbers, and then just multiplied by that 3. So that, we kind of already did that in an example. This just says if you have two terms added together in a summation, you can separate them into their own summations. So for instance, on this one, I could have separated this into 2 summations. And then same thing for subtraction. So those make sense. Okay, so that is it for example 8 and summation notation on lesson 8.1.